Okay, hello everyone. So this is about dynamic memory allocation. It's like a small video with some basic concepts. So dynamic memory allocation, we ask the operating system to give us memory at the runtime so that we can use it for our program purposes. So how we do that? So there are very simple, basic three, four steps, and we must take care of dangling pointer and memory leak. I will introduce these two topics two concepts shortly. So how do we do that? So we start with this statement, which is a statement new, and then the type of the variable that we want to create. So this is dynamically created, which means that it would be created in the heap memory. So whenever we write this statement, it requests the operating system when our program is running that we need an a place for an integer variable. So the operating system allocates us memory for that, which means that in case of int it would be 4 bytes, in case of double it would be 8 bytes. So now if when we get 4 bytes here with this statement, we want to access that for some operations, so that we can use that memory, like those 4 bytes as an integer. So for that operating system, this command returns us with the address where this memory is allocated to us. So we need to know that address. So we know that whenever we get an address, we have pointers to store those addresses. So we have already declared this pointer here, which is of the same type. So this is integer and this is integer. So this pointer will hold the address that would be the address of those 4 bytes which are just allocated by the operating system. So now we can easily using that pointer, we can use that memory for whatever purposes we want in our program, but this is dynamically created, so that has to be remembered. So we can just dereference it, we can assign some value to this, we can use cin to get some input, some value from the user, and put that in the memory location where this has been allocated to us using this dereferencing, because p is pointing to this already allocated memory. And we can do C out, we can use it in expressions and all those kind of things that we do with normal variables. Okay, so just to make a comparison between this way of dynamic memory allocation and static memory allocation, so this statement is creating this pointer and then this dynamic memory and allocating the it's assigning this address to that pointer and then using that pointer to assign 100 to that memory location is just same as we used to do with these two statements. So it's here what we are doing is we are just creating an integer variable p, and that means that we have 4 bytes reserved, and we can put 100 in that location, and we access that location by the name p. So this is a named place, right? But this way of declaring variable puts this variable in the stack memory, but here it is the heap memory, which means that we can just create more and more. So we don't have any restrictions. We can create lots of memory, and I will tell how that can escalate as well. So the next thing is whenever we create memory using this new operator, so whenever we declare or allocate memory dynamically, it is our responsibility to delete that memory as well, so that operating system knows that we do not need that memory anymore. Because in this case, in normal static variables, whenever that variables goes, if it is a local variable and it is in stack, whenever this goes out of scope, the memory would be deallocated. So we will not have that. The program will not have that 4 bytes anymore when this variable goes out of scope. So if I, for example, say that okay, if I define the scope like this one, um, so that means that outside these parentheses, like here, we will not have that 4 bytes. But in case of dynamic memory, so because this is in the stack, unless it is global or it is static, in that case it would have more lifetime. But here in dynamic allocation, when we declare like this, so we can say that p pointer is in the static because this is not dynamically created, right? So this is static. So it would be in stack. So we can say that this scope of this variable or lifetime of this particular pointer can be less, but the dynamic memory that we are getting here, or the memory that that has been given to us on the heap, that will remain as long as we are using it, this program. So that means that we need to delete that memory. So that's important step. So we must delete memory given to us by the operating system by using delete p. So what does that statement mean? It means that this is the reserved word delete. So we use delete p, which means that we want to say that we want to deallocate the memory that is pointed to by p, because p was pointing to this one so already, and so we can just say that okay, we want to delete it. So then the operating system knows that p is of integer data type, so 4 bytes would be deallocated, and then we will not have access to that. We should not have access to that memory. So if we do not delete that memory, it leads to memory leak problem. And what does that mean? That if we are just creating these new int and new int again and again, that means that we are not able to access that because pointer would be pointing to the new location. For example, if I write this code new double, or even if I write p equals to new double, so and this I run this program in just these two statements in a program, and that means the infinite loop. And what it would do is it would create double for 8 bytes. So 8 bytes every time will be allocated in the heap memory, and the or pointer would be pointing to that the first time to that memory location which is allocated. But then we next time this loop would run again, and then new 8 bytes would be allocated, and this pointer would then start pointing to the newly allocated 8 bytes. So the previous 8 bytes would not be accessible anymore because we don't have any way to reach to that address, because we have not stored that address anywhere. So P is now pointing to the new 8 bytes that we have just requested, and operating system allocated to us. And if at the third time it runs again, so we get 8 more bytes. So now we have 8 into 3 is 24 bytes. But now, right now, P is pointing to the last 8 bytes that have been allocated, and the previous 16 bytes are leaked. So that is memory leak that's happening here. And if we run this program, if it would result in memory leak of our system actually, which would mean that if you try to do that and run this program and then see the task manager and see what how memory is behaving. So you'll see that memory is getting more and more. So memory consumption would get more and more, and eventually you will not have any memory with, and that would just slow down your PC, and maybe you will not be able to do anything, and eventually you need to restart your computer. So try that. That would be interesting. So this tells us that we should avoid memory leak problem by delete statement. So that is very important. Okay. So the next important thing is once we delete that, our job is not done yet, because even though it will not create any errors, but if I write a statement like this, for example, if I say static p is equal to 200, so now this 200 would be assigned to that memory location where p is pointing. So delete p does not mean that pointer is not pointing there anymore. Delete p means that the memory location which was allocated here, it is not available to us, and we should not use that memory. But the pointers are so powerful that we can still use that, so that even though that memory is we have already asked the operating system to get back that memory. So if we write this statement, the program would still write 200 on that memory which was that place which was allocated here, and this was deallocated here, but still we will be accessing that, and that's a problem. And that means that we should not be able to do this. So this the way once we have deleted that pointer, and not pointer, the memory, this pointer is still pointing to that memory, which means this is called a dangling pointer. So what we must do after every delete statement for the pointer, we must also uh, assign null to p, or a p is equal to 0, we can say, which means that pointer p is not pointing to that memory location anymore, and p is not pointing to anything. And if for example we do static p at this stage, the program will crash, but it would not do any corruption or anything wrong with the other programs running in parallel on this machine. So this is all about using pointers. So how we dynamically allocate memory for a single variable, and what is a dangling pointer, and what is a memory leak problem. So in my next video, I will talk about using dynamic memory allocation to create dynamic arrays. So thank you very much.